Hi everyone, for this question it asks us to solve the following differential equation. So given that dy over dx equals to x e to the power of x minus 2y. So first we have to determine whether we're using separable method or IF. So we will try to see whether we can factorize out the unknown y or unknown x. So looks like we have an unknown y here. We simplify this exponential where it will become multiply with e to the power of negative 2y. So it means that e of the negative 2y can be factorized out from the term involving x. So when the variable y can be factorized out, take out from the multiplications here, which means this dE will be solved by separable. So for the y, we will move to the left hand side. For dx, we will remain at the right hand side. So e power negative means 1 over 2y. Then when we want to move it to the left hand side, this division will become multiplication. And then this denominator dx will be multiplied out. Then we start integrate both sides. So when you want to integrate both sides, this one e to the power of linear, we can use formula, but this one x, ex, we have to use integration by part. Alright, so we have two functions multiplied together, and we can see this function does not have any relationship where fx and f prime x. So to integrate that, we're using by part. So in by part, what we need is the formula integrate u dv equals to uv minus integrate v du. So we must identify which part to be u, which part to be dv. So u will be selected using the concept of law of pecks, where we will pick up the log function followed by polynomial, exponential, and trigo. So we have here polynomial, this is exponential, so priority we will select for x. Then the remaining of the part here, ex dx will become dv. So u we're going to differentiate respect to x so that we can find du in the formula, which is equals to dx. Meanwhile, for dv, we need to integrate both sides so that we can find out what is our v. Integrate ex, we get ex. Therefore, integrate x, ex dx will equals to u times v minus integrate v du, which is dx. So integrate ex, which is ex, plus c. So after we done this right hand side, we continue for here. Integrate exponential, so exponential 2y over the coefficient of the y. Then integrate this, we get x ex minus ex plus c. So we get to the general form first before we going to substitute these two values. So for 2, we move it to the right hand side, times 2 for every term. So 2 times c, we can continue still at remain as c because constant which are same. Then for e, when we move, we're going to log for everything here. Then finally y is 1 over 2 ln for this term. Then we continue to the particular solution where we can see what we get here is general form. general solution. So for particular solution, they give us y in the bracket of 0 equals to 1, which means y in terms of x. You can see our DE here is y and x, means y in terms of x, when x is 0, y is 1. We substitute inside. So 0 times exponential 0, this one, negative 2 power 0, then plus c. We try to find out what is the constant c here. So we move back, here is 2. This is negative 2 plus c. Then ln we move back, it will be e to the power of 2. So c is e power of 2 plus 2. Then finally, we put back into our solution. 1 over 2 ln, then 2x ex minus 2ex, where c is e squared plus 2 in modulus. Modulus just to make sure our function here always positive, so that the function of the log will be valid. Okay, so that's all for this.